All right, so if you solve the system equations by those three methods, the answer that you should have gotten, just so you can check that your answer was correct, was -2, -3. So let's move to the second and third page of the notes. So you might want to pause the video and make sure you understand the difference between these different types of systems. And once you're done, unpause the video. Now, when you have a system that has no solutions, which is an inconsistent system, or you have a system that has infinite solutions, which is consistent and dependent, when you solve by substitution or elimination, something interesting will always happen. Let me show you what this will look like. So I got this system. I'm going to solve this by, let's say I'm going to solve it by elimination. So I'm going to eliminate the x's. So I'm going to multiply this top one by 4. And this bottom one by -6. So this would be 24x plus 36y equals 48. And this would be -24x minus 36y equals -54. So if I look at this, my x's go away, my y's go away. So on this left-hand side, I have 0. And on this right-hand side, I have -6. Okay, so whenever you have a system that either has no solutions or infinitely many solutions, when you do elimination or substitution, all the x's and the y's will go away, like this. And you'll end up with something that looks like this, with just numbers in it. That's an indication that it's either inconsistent, which is no solution, or infinitely many solutions, which is consistent dependent. Now, the way you can tell the difference between those is if all your variables go away and your resulting statement is not true. And the resulting equation is not true. Like this one. 0 does not equal -6, then that means the system is inconsistent. There's no solution. Whereas if you went through this and all your variables went away and what you're left with is true, something like 0 equals 0, or -6 equals -6, or 12 equals 12, then it's consistent and dependent and therefore has infinitely many solutions. All right, so you should now know how to do substitution and elimination and graphing to solve the systems. You should know how to recognize an inconsistent system or inconsistent and dependent system if you're doing substitution or elimination. And now let's talk systems of inequalities. Now, when you're solving a system of inequalities, the system is never a single point. But instead is a range of points. So what we're looking for here is not like a single answer, but something that represents an infinite number of points all kind of landing in the same range. Because of this, only one method is going to work for solving a system of inequalities, and that's graphing. In fact, when I ask you to solve a system of inequalities, the answer is the graph, and I'll show you what I mean by that. So I've got a system here, so I'm going to draw some axes. And remember, when you're solving by graphing, you basically graph each of the things that are there. So I'm going to graph the bottom inequality. Let's graph that one in green. So the y-intercept would be -1. The slope is 1/2, so up 1, right 2, up 1, right 2, so forth, so on. It is a solid line. And when I test the point 0, 0 in it, I get 0 is greater than or equal to 0 minus 1. So is 0 greater than or equal to -1? And the answer to that is yes. So where my test point was, which was at 0, 0, I would shade that way. And now I'm going to graph my other inequality. And I could get this into slope-intercept form and then graph it, and that would be fine. I'm going to find the y-intercepts instead and the x-intercept. So the x-intercept on this one, if I plug in 0 for the y, would be 2, which is here. And the y-intercept is what I get when I plug in 0 for the x, and that would be -3, which is here. This one's dotted, and if you notice I went right 2 and down 3, so I'm going to draw another point just so it's a little easier for me to draw this. Make it dotted. So if I test 0, 0 in that, I get 0 is less than 6. Test point was right here. That's true, so the solutions to that are all here. Now, the solution to this system of inequalities is where those two shadings overlap. So what I would want to do is at the end, I would want to go back and emphasize that area where they overlap, just so I know that you know that that's the answer. So the process for solving a system of inequalities is to graph one, graph the other, mark the overlap, and that overlap is the answer. Now, unlike systems of equations, with inequalities, you can have 2 or 3 or 4 of them all happening at the same time, but the process is the same. You graph them all, and where they all overlap is the solution.